We are here going to be looking at tables that were being made by an artist who works with 18-inch tiles as the tabletops. 4 tiles makes a 36 by 36-inch table. She uses these 4 color tiles. So here are some sample tables that can be made. Notice that even though the colors are the same in these 2 tables, they're not the same table. You can't rotate one of these tabletops and produce the other from it. To see that, for instance, think about sitting at the blue-green side of this table. Your left hand will be on blue and your right on green. If you sit at the blue-green side of this table, it will be your right hand on blue and your left hand on green. So these are not the same table. Here's another illustration of tables that are the same in this case at the top, but different at the bottom. The table at the top, the 2 tables at the top are the same because if you take this table and rotate it 180 degrees, you have this table. So you can simply, by turning this table, see that this one is the same table really, just a rotated version of it. You can't do that with the 2 at the bottom. They are in effect mirror images of each other, so you can't produce one from the other by rotating it. The questions we're going to answer are: how many tables can she make using only 1 color tile? How many can she make using 2 different colors? How many using 3 different tile colors? How many if she uses all 4 colors, as are shown up here? And finally, what's the total number of different tables that she can make? Obviously, if she's going to use all green tiles, there's only 1 table she can make, a green table. And similarly for the other 3 colors. She can make 1 solid color table from each color. There are 4 colors, so that means there are 4 possibilities for solid color tables that use only 1 color. Next, let's think about all the tiles we can make with 2 colors, and let's start by thinking about just red and blue. If you're going to make a table using just red and blue tiles, you really have only these 2 choices. If you're going to use 2 tiles of each color, you can either put the 2 blue and the 2 red tiles so that they're side by side, or so that they are diagonally in contact. And there really aren't any other possibilities if you think about it. You can, of course, rotate this table and make it look different, but it's still the same table. So you've got these 2 tables that can be made using 2 tiles of each color. And you've got these 2 tables that can be made using 3 of one color and 1 of the other color. So this is really all the tables you can make out of red and blue. Now altogether, remember, we have 4 colors. If you're going to use just 2 colors, you can choose which 2 colors you're going to use in combinations of 4 times 2 different ways. That's 6. So there are 6 ways to choose 2 colors, and then whichever colors you choose, you can make 4 tables as we've illustrated right here. So that demonstrates that altogether there would be 6 times 4, or 24 different 2-color tables. 6 choices for your colors times 4 different tables you can make using any 2 colors. Now let's move over here and think about tables that use 3 colors. The first thing to understand is that if you're going to use 3 colors and make a table that uses 4 tiles, the only way to do that is to have 2 tiles of 1 color and 1 tile of 2 different colors. So for the 3 colors we're using, there has to be 1 of those colors where we're using 2 tiles, and the other 2 will just be made up of 2 different tiles of 2 different colors. So in this illustration, I'm using blue for the color where there will be 2 tiles, and red and yellow for the colors where there will be 1 tile. And if you give it careful thought, you'll realize that these are all the tables we can make using 2 blue tiles, 1 red tile, and 1 yellow tile. This table is obviously different from the other 2 because the blue tables are diagonally opposite each other. Why are these 2 tables different tables? Well, they're because if you're sitting opposite the blue squares, on this table, your left hand is on red and your right hand is on yellow. If you're sitting opposite the 2 blue tiles at this table, your left hand is on yellow and your right hand is on red. So these tables are different. You can't rotate one and get the other. These are the only 3 tables you can make using 2 blue tiles, 1 red and 1 yellow. Now, the same would be true if we took any other combination of colors and took 2 tiles of 1 color and 1 tile of each of the other 2. So let's now think about how many ways to pick which colors we're going to use in this example. Here I've got 2 blue tiles. If I'm picking a color to use 2 tiles from, I've got 4 colors to choose from. And then after I've picked a color, say blue as the color where the 2 tiles are going to be used from, I've still got 3 colors left to pick the other 2 colors, in this case red, yellow and red. So having chosen blue as the color for the 2 tiles, I can pick which 2 colors to use for the other 2 tiles by picking any 2 of the other 3 colors. How many ways to pick the 2 and then how many ways to pick the other 2 colors for 1 tile is 4 times 3 or 12. So we have 12 options for choosing a color for 2 tiles and 2 other colors for 1 tile each. So just as we've illustrated here with 2 blue, 1 red, and 1 yellow, the different combinations of color would give us 12 ways of producing 3 tables like that. So we multiply 12 times 3 is 36 different tables altogether that could be produced using 3 different colors. And finally, let's think about how many tables we can make using all 4 colors. Turns out these are the only 6 different ones you can make. Let's see a pattern. Let's observe a pattern that tells us why there should be 6. And to do that, let's think about fixating on the green tile. If I'm going to start at the green tile and travel around the table clockwise, in this table I come to red, blue, yellow. In this table I would come to red, yellow, blue. In this table I would come to yellow, blue, red if I start at the green. So if you think about it, you'll see that starting at the green tile, and I picked that out just as an example, if I start at the green tile, traveling around the table clockwise, it's really just a question of how many different ways I can list these other 3 colors in order. For this table, it's red, blue, yellow. Here it's red, yellow, blue. How many different ways can I list those other colors in order? Well, I've got 3 spots. Putting 3 things in 3 spots can be done in 3 factorial ways. 3 times 2 times 1, which is 6. So that's why we get these 6 different possibilities. It's because it's just 3 factorial. So we've answered all the questions that were originally posed. 4 tables could be made that involve 1 color. 24 tables can be made out of 2 colors. 36 can be made out of 3 colors. 6 can be made using all 4 colors. Add those numbers up, and you get a total of 70 different tables that the artist can make.